Infinite series. Partial sum of an arithmetic series is the same formula that we used before, and that would be the sum sub n equals n over 2 times a sub 1 plus a sub n. So that's the formula we're going to use to find the nth sum of an arithmetic series. So, for example, if we wanted to find the partial sum, the 150th partial sum of 5, 16, 27, 38, 49, etc. We know this is an arithmetic series because if we look at it, we see 5 to 16, that is a difference of 11, 16 to 27, difference of 11, 11, 11, and so on. So our common difference is D, and that is 11. Now, if we remember back to our arithmetic series, which you have to know, a sub n equals a sub 1 plus my D times n minus 1. Okay, so if I put in what I know, a sub n equals a sub 1, which is 5, because that is my first term, plus 11, because that is my D, times n minus 1. Now you can't leave it like this, you always have to simplify, so we distribute, and we have a sub n equals 5 plus 11n minus 11. So my final equation for my arithmetic series is going to be a sub n equals 11n minus 6. Now the reason why I wanted to find that is because I need to find my a sub n. And since I want S sub 150, that means I need to find A sub 150. So it would take a long time to actually add it 150 times. So I'm going to take that shortcut. So I have my A sub 1, which equals 5, because that is part of my partial sum series. And then I need to find my a sub 150. Well, then I just put 150 in for n. So 11 times 150 minus 6. Okay, so that obviously just type it into the calculator. And when you do that, you get a sub 150 is going to equal 1,644. So now I have a sub 150 and a sub 1, so I just put that in, and I have n, which is 150, divided by 2 times 5 plus 1,644. So if I type that into the calculator and simplify it, I get 75 times 1,649. And then my final answer, S sub 150, is equal to 123,675. So the 150th partial sum would be right there. This time I want to find the 223rd partial sum of 6, 9, 12, 15. So this time, if I'm looking at my difference, 6 to 9, difference of 3, 3, 3. So we're adding 3 each time. So my D is equal to 3. And my A sub n equals my A sub 1, which is 6, plus my D, which is 3, times n minus 1. Simplify. So 6 plus 3n minus 3. And simplify completely, a sub n equals 6 minus 3, which is 3, so 3n plus 3. So that is my a sub n term, so now I can find the 223rd term. So that would be a sub 223 equals 3 times 223 plus 3. So if you type that into the calculator, you get a sub 223 equals 672. And we already also know that my a sub 1 is 6. So I have those two important pieces of information, and I can put it into my formula. S sub 223 is equal to n, which is 223, divided by 2 times 672 plus 6. So that would be 223 over 2 times 678. All right, and then I just type that into the calculator, and I have S sub 223 equals 75,597. And that's your final answer. Now, the sum of an infinite geometric series, we can actually find the sum of an infinite geometric series. That means it goes on forever. And there is a special formula that we can use to solve those. And that formula would be S sub infinity is going to equal the summation of all I equals 0 to infinity of a sub 1 r to the power of I, or it's also going to be equal to the summation of I equals 1 to infinity of a sub 1 r to the I minus 1. So those are both the same thing, and that's also equal to our generalized formula of a sub 1 over 1 minus r. So that would be the key thing that we're going to be working with. So if we were to do this first example, we want to find the sum of I equal 1 to infinity of 4 times 0.6 to the I power. Okay, so obviously we'd have to put in 0, and then put in 1, then put in 2, then put in 3, all the way to infinity, which is impossible. So we have to use our generalized formula, which is a sub 1 over 1 minus r. So find my a sub 1. My a sub 1 is going to be whatever my initial term is right there. Because if you look at my formula, that's where my a sub 1 term is. So a sub 1 is equal to 4. And my r is going to be equal to whatever the base of my power is. So that would be the 0.6. All right, so now I have my a and my r, so if I put it in, I have 4 over 1 minus 0.6. That's going to give me 4 over 0.4. As long as it's all decimals, you might as well just keep using decimals. And then you divide that out, and we get S sub infinity equals 10. Final answer. For this next example, same thing. We want to find my a sub 1. And we want to find my r. Now in this one, we have I equal 1 to infinity, but we also have I minus 1 in the exponent. So it's the same thing. It doesn't matter. So my r is still going to be whatever the base of the exponent is, which is the 1/2. And my a sub 1 is still going to be the number multiplied to it, which is 5. So there we go. Okay, so the next thing is put it into the formula. A sub 1 is 5 divided by 1 minus my r, which is 1/2. So that gives me 5 over 1/2. If I invert and multiply, then my final answer is going to be 10. So S sub infinity equals 10. Now keep in mind, these were just two special cases where they both happen to equal 10. This does not mean that every summation always equals 10. That is not true. So you actually do have to go through the formula. We just kind of got lucky that they both happen to be the same thing in this case. Those are your notes over infinite series. Go through some practice problems, and then you can prepare for your quiz over summation of infinite series.